All right, so I think that I'm recording here. Let's take a look at this problem number 2. They give us two functions f and g, and they ask us like 9 different things to find using these two functions. So let's take a look at the first 3 here. They want us to use these two functions to build some new functions, and in part A, this new function has the title f plus g, so that serves two purposes, not only as a name for the function, but also how this function is constructed. So my answer for part A, this new function f plus g of x is just simply 2x plus the square root of x minus 6. All we have to do is simply add these two functions together. There are no like terms to combine, so that's our final answer. In part B, we're asked to just simply multiply these together, and rather than call this new function something like h, we give it a title fg, and that tells us how this new function is constructed. So like I say, it gives it a title, but it also tells us information of how to build it. So we just take 2x times x minus 6. In part C, we have division. We want to divide these two functions. We could have called this new function something like h, but calling it g over f gives us a clue as to how to build this function. So we take this function g, divide it by the function f. But they expect us to rationalize denominators. So our final answer here is 2x times the square root of x minus 6. And here, although technically we're supposed to have absolute values around this x minus 6, since x always has to be greater than 6, then I know that this, and it can't equal 6 because it's in a denominator. So being bigger than 6, x minus 6 is going to be some positive amount. So I don't need the absolute values. So there's our answers for the first 3. Let's take a look at what else it asks us in problem number 2. We want to find the domain of f plus g, g times f, g over f, and f over g. So to find the domain of this new function, f plus g, see, I erased what it was. I really don't need the function because I have how the original functions of how it was built, and that's better to use to determine this domain anyway. Let's look at the product. These two will always, no matter what the functions are, these two will have the same answers because we're going to intersect the domain of f with the domain of g for both of these, for D and E. Now, for f, part F, it may be the same answer that we have in D and E, or it may be more restrictive because we have an added consideration that the denominator f of x, we can't have values of x in the domain, that would cause f of x to be 0. And the same idea here for f over g. It might be the same answer as D and E, but it may have an added restriction because we have to avoid letting g of x, the denominator, equal 0. So let's find our answers to D and E, which we know are going to be the same. But first, we have to find the domain of f and the domain of g. The domain of any function is always the set of all real numbers, excluding any values that cause division by 0. Well, we don't have any variables in a denominator for either one of these, so that doesn't come into play. In f, we do have a square root, so we have to make sure that we're not taking the square root of a negative number. So x has to be 6 or larger, otherwise that subtraction is a negative number. So to be 6 or larger, here's 6 all the way to infinity. The domain of g is all real numbers because we don't have any variables in a denominator and we don't have any variables underneath the square root. Now, when we intersect these two sets, to be in the intersection, you have to be in both sets. So the domain for f plus g, like we said before, it's going to equal the domain of g times f because we intersect the domain of f intersected with the domain of g. This symbol is for the intersection. It translates to the word and. You have to be in this set and you have to be in this set to be in the intersection. So 6 is in both sets, but numbers that are less than 6 are not in both sets, so they can't be in the intersection. So our answer for D and E is those domains are greater than or equal to 6. X greater than or equal to 6. Let's now think about how to find the domain of f, part f. We want to find the domain of g over f. So it's going to be this domain plus maybe an added restriction because in part f, we can't allow f of x to equal 0. But in order to figure out what x would cause an output of 0, we temporarily say, okay, let's let f of x equal 0. And f of x, of course, is defined to be the square root of x minus 6. So if you square both sides and add 6, it's obvious that 6 minus 6 gives us 0. So f evaluated at 6 is 0. And remember, we don't want that to happen. So we have to exclude 6 from the domain. So we said it would be the same answer as D and E plus any possible restrictions. The restriction is we have to remove 6. So for part f, the domain of g divided by f is from 6 to infinity, but excluding the number 6. All right. So what about this part over here? Is that an I or a J? I think that's an I. It might have the same answer as parts D and E, but we might have to add a restriction just like we did say in F. Here in this part I, the extra consideration is that denominator cannot equal 0. But we temporarily let it equal 0 so we know what to avoid. This time g of x is 2 times x, and 2 times 0 is 0, so this has a solution of x equals 0. So what we've just figured out, that g evaluated at 0 is equal to 0. We want to avoid that. We want to exclude 0 from the domain. We don't want x to be 0, but take a look at the intersection. already it's excluded because 0 is smaller than 6. So our domain for f divided by g didn't have any additional restrictions, so it's the same answer as D and E. All right, so I hope that helps with those. Let's erase this and move on. That there's either 2 or 3 more to do. Do I need these answers? I don't believe so. I'm not going to erase the domain of f and the domain of g. All right. Yeah, we've got 2 more to think about. And they're both finding the domain of a function composition. So just like before, we think about how these new functions are constructed. We don't necessarily have to find the expression for these new functions. We just have to think about how they were constructed. Well, in function composition, you kind of need to think of it like an assembly line. So in part K here, and remember that we start with the second function here, g composed with f, we start with f. And the idea is that we give input to f, and the output of f becomes the input for g, and then the output of g, after it went through f, the final output here is our final answer. So we give we pump in some value as input into f, the output of f becomes the input for g, and this, so to be in the domain, we have to make it through both functions. The output has to be well defined. Well, in order for any number that we give f to have an output, we've already said that for x to be in the domain of f, to have f of x be a real number, then we have to have x be in the interval from 6 to infinity. Now, the output of f has to be in the domain of g. But g wasn't very picky at all. The domain of g is all real numbers. So any output of f is going to be fine as input for g. So the domain of this function composition turns out to simply be the domain of f, that first function. This g didn't add any other restrictions. So we have g composed with f, the domain of this being 6 to infinity. And here's our answer for part K. For the next composition, see, order is important in function composition. Now we begin with the function g. And 2 things have to be true. The input into gx has to be in the domain of g, and the output of g that becomes the input for f this output of g has to be in the domain of f. All right, so the domain of g was all real numbers, so we don't have any problems here. Anything that we plug into g, we're going to get an output. But f is more picky. F, the output of g, has to be a number that is greater than or equal to 6, because f cannot have input that is smaller than 6, because then it would be taking the square root of a negative number. Well, g of x is just the expression 2x, so 2x has to be greater than or equal to 6, which means that x has to be greater than or equal to 3. So although g doesn't have any restrictions at all, f does have restrictions. And in order for us to, for this output of g to be 6 or bigger, the input into g has to be greater than or equal to 3. So our domain for this function composition is 3 to infinity. So I hope that helps with number 2. Ask any questions. Let me know if you disagree with any of these answers and we can talk about it. Talk to you later. Bye.